So here are the solutions for the multiple choice problems on the review. Number one, the Gallup poll interviews 1,600 people. Of these, 18% say that they jog regularly. The news report adds the poll had a margin of error of plus or minus 3 percentage points at a 95% confidence level. You can safely conclude that. All right, so let's check out each of the conclusions. A says 95% of the population jog between 15 and 21% of the time. First of all, the confidence interval describes the true proportion, not the individuals. And this is talking about individuals being between 15 and 21%. So that is incorrect. B, the percent of the population who jog is certain to be between 15 and 21%. We can never be certain of the true value of the population proportion. The only way we could actually know that is if we took a census, and it's very hard, pretty much impossible in many situations. C, we can be 95% confident that the sample proportion is captured by the confidence interval. So this one's super tempting to pick until you notice the word sample proportion. We're actually 100% sure that the interval captures the sample proportion because that's what we use to calculate the interval. So that was sort of a tricky one there. Catch that word sample. If that had said true proportion, this would have looked much better as an answer choice. D, if Gallup took many samples, 95% of them would find that 18% of the people in the sample jog. That seems pretty specific. It's not, the confidence interval is about the true proportion, not about any particular sample proportions. And then finally, E, 95% of all Gallup poll samples like this one give answers within plus or minus 3% of the true population values. So this interprets the confidence level, which is in page 4 of your packet. If you use a C% confidence intervals, often about 60% of your intervals will capture the true parameter value, which is E. Number 2, a confidence interval for a difference in proportions is negative 0.077 to 0.013. What are the point estimate and the margin of error for this interval? So let's pretend I have the interval sort of on a number line. And the midpoint is the point estimate. So how do I find the midpoint? I can just add the two ends and then divide by 2. So that gives me a midpoint or point estimate of negative 0.032. So my choices are down to A or B. Then my margin of error is basically, it's plus or minus, so it's half the width of the interval. It's from either end to the midpoint. So I can take my margin of error and say, okay, it is that midpoint estimate right there, that negative 0.032 minus negative 0.077, which gives me 0.045, which is the answer. Number 3, in a random sample of 100 students from a large high school, 37 regularly bring a reusable water bottle from home. Which of the following gives the correct value in interpretation of the standard error of the sample proportion? So first we want to go ahead and make sure we look at our math chart, and that's what it shows for standard error of a sample statistic. We'll need p hat. You can see it's right in there, so it's not a hypothesized value. It's a value from a sample that we're going to put in there. So p hat is the 37 out of the 100 students, so it's 0.37. Substituting in 0.37 into the formula, we get 0.048. So you can see we've got a couple 0.048s and a couple 0.095s, and then someone says, oh, there's not enough information. Yes, there is. So it's either B or D. So how do we interpret standard error? Well, standard error is the typical distance between the sample values and the true proportion. So it's D. In samples of size 100 from this school, the sample proportion of students who bring a reusable bottle from home typically varies by about 0.048 from the true proportion. Number 4, many television viewers express doubts about the validity of certain commercials. In an attempt to answer their critics, Timex Group USA wishes to estimate the true proportion P of all consumers who believe that it is shown in what is shown in Timex television commercials. What is the smallest number of consumers that Timex can survey to guarantee a margin of error of 0.05 or less at a 99% confidence level? Now, by the way, this is not going to be the actual smallest. They're really asking which one of these could you use for the smallest sample size. So we need to have the equation with margin of error. You remember we just did this one for standard error, and we need a critical value. So 99% critical value, you would do inverse norm on your calculator, which you get to by hitting second distribution. And you set the confidence level for 0.99, the mean is 0, the standard deviation is 1. This is for critical values. And make sure you specify the center. So 2.576. Don't worry, I'll show it to you on the next problem on the calculator. Okay, so that's my critical value. And also, we don't have a beginning p hat to start this. So we're going to assume the worst case scenario, which is p is actually 0.5. So substituting in the 0.05, which is the margin of error here, right? So there's the 0.05. Here's the critical value, and then there's the 0.5. 1 minus 0.5 is 0.5. By the way, so that's 0.25. Then I square both sides. So I get 0.05 squared, 2.576 squared, and when you square something in the square root, it just pops out. And when we multiply out, we get 0.0025 equals 1.6589 divided by n. And I can just multiply both sides by n, and then divide both sides by 0.0025. And I get 663.58. So if you look at the choices, I don't really have 664, which is what I need. So you always round this up regardless of what you have over here on the right of the decimal. So we're going to use 664. 650 is not big enough, but 700 is. So that's what we pick for our sample size. Number 5, which of the following is the critical value for calculating a 94% confidence interval for a population proportion? So this is that inverse norm again with mean of 0 and SD of 1, and we do the center area. So let's show this. There you go.
Critical value for 94% confidence interval. You hit second distribution. We're not doing normal CDF, that's to find area. We're trying to find the critical value, so we're going to do inverse norm. And the area we're doing, because it's a 94% confidence interval is 0.94, and it's 0, and then it's 1, and then of course you want to make sure that it's centered, and you hit enter. And you can see you have two values, negative 1.88079 or negative 1.881, and positive 1.881. When talking about critical values, we always use the positive values, so never give the negative. You can see one of the answer choices is negative. Now let's say you're using an old school calculator, so we're going to go second distribution, and these calculators do not have the option of center or right. In fact, you don't see it for the tail, but it's going to tell you the tail is defaulting to the left. It's sort of working in percentiles. So if I have the middle 94%, right, that leaves 6% on each end. So, well, total on split between the ends. So we have 3% on each end, right? So if I add that 3% to the beginning and I change this to 0.97, right? So there's still 3% left on the right, and I say left tail because it's an old school calculator, and I hit enter. You'll see we actually have the same value. There you go. So that's how you do it with the easy way, being able to say center for your tail, and then if you have an old school calculator and you're stuck calculating here.
So your answer is 1.881. Number 6. A radio talk show host with a large audience is interested in the proportion P of adults in his listening area who think the drinking age should be lowered to 18. To find this out, he poses the following question to his listeners. Do you think that the drinking age should be reduced to 18 in light of the fact that 18-year-olds are eligible for military service? He asked listeners to go to his website and vote yes if they agree the drinking age should be lowered, and no if not. Of the 100 people who voted, 70 answered yes. Which of the following conditions were violated? Now, first of all, this is not technically part of the conditions, but you can see how he worded it, right? So there is a response bias. But the thing, because we're talking about these three conditions, I'm going to focus on them. So the random condition is taking a random sample. He does not, oops, what was that? Hold on. There you go. He does not randomly sample listeners. They volunteer. So the random condition is not met. Now, the next condition is 10%. So hopefully 100 people is less than 10% of his listeners. So the sample needs to be smaller than, or no larger than really, 10% of the entire population. We have to assume he has at least 1,000 listeners since he has a large audience. So this condition is met. So condition 2 is met. Then the large counts condition, we look at the number of successes. So there were 70 that said yes, so that is at least 10. And then we look at failures. How many were left over? 30. That is at least 10, so this condition is met. The only condition not met is the random condition. Number 7. A marketing assistant for a technology firm plans to randomly select 1,000 customers to estimate the proportion who are satisfied with the firm's performance. Based on the results of the survey, the assistant will construct a 95% confidence interval for the proportion of all customers who are satisfied. The marketing manager, however, says the firm can afford to survey only 250 customers. How will this decrease in sample size affect the margin of error and the confidence interval? All right, of the confidence interval, really. So we have a smaller sample, so the interval is going to be larger. It's not going to be A, B, or C. We use the square root of the factor to determine impact. So this is a 4 times difference, going smaller. So square root of 4 is 2. We know our margin of error is going to be larger, so we're going to say 2 times larger. Number 8. 35 people from a random sample of 125 workers from Company A admitted to using sick leave when they weren't really ill. 17 employees from a random sample of 68 workers from Company B admitted that they used sick leave when they weren't ill. So we've got 2 samples here. You kind of get a hint because we're seeing all these proportions, right? So, which of the following is a 95% confidence interval for the difference in proportions of workers at the 2 companies who admit to using sick leave when they weren't ill? So this is the format you have, and this is from page 2 in your H packet. We have all those formulas written down for you. So this is going to be our point estimate, our critical value, and our standard deviation for the difference of 2 proportions. Now you're probably going, but wait, that's a plus sign. Well, think of these as variances, and we always add variances to get, then we go take the square root to find our standard deviation. So you can automatically eliminate C and E as answer choices. Now let's calculate the point estimate. P1 is 35 out of 125, or 0.28, and P2 is 17 out of 68, which is 0.25. So I'm going to put all these P1 hats, really, I should put a hat on these, and P2s in there. So yes, that's a boo-boo. I really should have a hat there. So 0.28 minus 0.25 plus or minus, we're doing 95%, so this is 1.96. And we have 0.28, 1 minus 0.28, and 0.25, 1 minus 0.25. All right, so we know we have this here is 0.03, so it's either A or B. We know it's not C because there's a minus there. Here we're missing the critical value, and there you can see the values are all correct, so the answer is B. Number 9, a telephone poll of a simple random sample of 1,234 adults found that 62% are generally satisfied with their lives. The announced margin of error for the poll was 3%. Does the margin of error account for the fact that some adults do not have telephones? So the issue here is that there is bias due to undercoverage because they're doing a telephone survey and not everyone has telephones. Well, the margin of error does not include any sources of error other than sampling variability. That is natural variation due to randomness. So the correct answer is A. So it has nothing to do with non-response, undercoverage, all that sort of stuff. Number 10. At a baseball game, 42 of 65 randomly selected people owned an iPod. At a rock concert occurring at the same time across town, 34 of 52 randomly selected people owned an iPod. A researcher wants to test the claim that the proportion of iPod owners at the two venues is different. So he constructs a 90% confidence interval for the difference, game minus concert, in population proportions, and he gets negative 0.154 to 0.138. Which of the following gives the correct outcome of the researcher's test of the claim? So if he's trying to say there is no difference, he's trying to see if there is a difference. No difference would be a value of 0. So the interval shows the plausible values given this level of confidence, right? 0 is in the interval, so it is plausible there is no difference. So because the interval includes 0, the researcher cannot conclude that the proportion of iPod owners at the two venues is different.